the signals. In today's class, we will be looking at some standard signals such as the impulse function, step function, signum, sinusoidal signals, exponential signals. So that we'll have an why we are calling these as the standard signals is the point, because whenever we build a system, whenever we design a system, we'll be uh, verifying the functionality of the system, or the response or the output of the system. Then we have to give some input. So as we know something better about these signals, okay, and we know how a system has to behave when this input is given like that. So these signals are said to be some standard signals. Okay, so whenever you want to do some analysis of a circuit or a system, we'll be giving these signals as input, and we'll be analyzing how that particular circuit or system is going to respond. Okay, so initially we'll test those circuits or systems, keeping view of these signals into account, right? So that's why these signals are said to be standard signals. That's the only point. Okay, right? So it is not that everywhere we have to use only these signals. No, it is not like that. So once you can understand these signals and their behavior, obviously we can extend our concepts to the rest of the signals, or the signals which we encounter or face in real time. Okay, right? So uh, we'll look at initially about these signals. So the objective is to impart knowledge on standard test signals with emphasis on impulse, step, and signum functions. So at the end of this session, students will be able to represent standard test signals, interpret impulse function, and interpret properties of the impulse function. So you should have an idea of what these standard test signals and able to represent in the sense you should represent them uh, in a diagram manner, waveform manner, as well as in mathematical format. And then you have to understand what actually the impulse function and its properties, right? Yeah, this is what I discussed. Standard or test signals helps in predicting the performance of the system. Okay, so when we build or design a system, we feed some input signals, and these input signals are the signals which we know their behavior. Okay, only those signals will be fed to the system, and obviously once we know the input signal behavior and we can see the output or obtain the response of the system for the given input. So based on that, we can understand or study or analyze the behavior of that particular system. Okay, so all these signals what we use to for this purpose are said to be test signals. So the commonly used test signals are impulse, ramp, step, sinusoidal, and so on. Okay, so first this is the list. Okay, we'll be looking at all the signals one by one, right? Unit step function, unit ramp, parabolic function. Yeah, so you don't confuse with this title as functions, because you are more familiar with function. We started writing this as functions, but you can write this as a signal also. Unit step signal, okay, unit ramp signal, parabolic signal, impulse signal, signal, sinusoidal signal, exponential signal, and rectangular pulse signal, right? So now first we look at unit step function. What is unit step function? Unit step function is a function or a signal which is defined in this manner. Okay, u of t is equal to 0 for t less than 0. For t less than 0, its value is 1 for t greater than 0. So now you can see it's a graphical illustration. For t less than 0, the blue line, now it is a red line, it is 0. There is no signal amplitude. Signal amplitude. Okay. For t greater than 0, it is 1. So you can see here from t greater than 0, it became 1. So it takes a step. step increment in its amplitude. That's why this particular signal is said to be step signal. That's why it is said to be step signal. So what is this step signal? Step signal is the one which is defined for t less than 0 and t greater than 0. For t less than 0 it is 0. For t greater than 0 its amplitude is 1. Now comes the point, what is this unit? Okay, what is this unit? Unit represents the magnitude. Okay, so we are defining the unit step function will take the amplitude only 1. Then it is said to be unit step function. Okay, instead of that, suppose this step function takes some amplitude, say a or k, say 5 or 3 or 10. Okay, instead of 1, when t is greater than 0, when t greater than 0, right? Then this once again this step function or step signal is said to be step signal, not a unit step function. Okay, this unit here before the step signal represents the amplitude is unity. The amplitude is unity. Okay, is it clear? Right?
Yes, sir.
So here we have seen the continuous version of the unit step function, where we have represented that one as u of t. Similarly, I can now show you the discrete time unit step sequence. Already I told you discrete time signal is simply referred as a sequence. Now you can see discrete time unit step sequence u of n is defined as u of n equal to 1 for n greater than or equal to 0, and it is 0 for n less than 0. So now you can see, okay, for n less than 0 it is 0 at minus 1 0 minus 2 0 minus 3 0, and for n greater than or equal to 0 its value is 1, unity. So once again the unity also holds good here. If the amplitude is 1, then only it is said to be unit step sequence. Okay, okay, simple thing. The definition is simply extended for a discrete type version. That's all. Now we move on to ramp function or ramp signal, where this ramp signal is defined as its amplitude is t. Amplitude is t for t greater than or equal to 0. For t greater than or equal to 0. That means at 0, see what is x-axis? X-axis is also t. What is x-axis? X-axis is also t. So at t equal to 0, what is the value of r of t? Amplitude t. That means its value is 0. Suppose if you make this, if you want to look at the amplitude at t equal to 1, then its amplitude is also 1, because we have given that r of t is equal to t. So whatever the values we are going to take on x-axis, obviously the amplitude is also same. Okay, so it becomes a linear curve like this, a ramp signal. Okay, a ramp, okay, whose slope is equal to 1. That's why this particular signal is called as a ramp signal or a ramp function. Is it clear? So at t equal to 5, what is the amplitude of the ramp signal? At t equal to 5, what is the amplitude of the ramp signal?
5.
Good, it will be 5. Okay, because we have given that r of t is equal to t, right? So what happens when t is less than 0, negative values? It is 0. For t less than 0, the amplitude is 0. Okay, for all the negative values of t, r of t is 0. Is it clear? Any doubts? Okay, right. You can also write r of t in terms of unit step function as r of t is equal to t into u of t. R of t equal to t into u of t. So what it indicates, obviously, you know already about u of t. U of t is the signal unit step signal where it doesn't exist for t less than 0. It will exist for t 0 onwards. Okay, so how this ramp signal is being defined? It is also defined for t greater than or equal to 0 only. So when you multiply that signal with this one, so this amplitude is always t. And what is the amplitude of u of t for all the possible values of t? It is 1. Is it not? So t into 1 remains t only. So this is another way to represent your ramp signal. If it is asked to represent in unit step signal or unit step function. Is it clear? Any doubt? Any doubt? Can you represent this is in continuous form? Can you represent this one in discrete version? Can anybody do it? You can try.
Yes, sir.
How you will represent? R of n
Is equal to
n, is it not? For n greater than or equal to 0, is it not?
0. Yes.
0 otherwise, is it not? For n
Then
less than 0.
0.
Right. So this is how you can have the signal. I hope I have, yes, I have the representation you can see here. So for n less than 0, it is 0. Okay. So for n greater than or equal to 0, you can see its value is only n. So when n equal to 1, what is its amplitude? 1. When n equal to 2, the amplitude is 2. Okay. When n equal to 3, the amplitude is 3, and so on. It goes on like this. Okay. This is the discrete time unit ramp sequence. Sorry, not unit. You have to say this as ramp sequence. Okay, where the amplitudes are not unity. Okay, right. And the other point is you can obtain the ramp signal through unit step function. So how you can do that is R of t can be obtained by integrating unit step function. So integral u of t dt. Integral u of t dt. You know, yeah, obviously the time limits you have to say that it starts from 0 to infinity. So what happens even if you write it as minus infinity to plus infinity, u of t doesn't exist from minus infinity to 0. So that integral value becomes 0. So we are taking only from 0 to plus infinity. Then what happens? Its value is 1. So integral 1 dt. What is integral